Welcome back, guys. We're going through the first question in Unit 5 Self Quiz. So we're given a class of 70 students. We have a random variable x that measure the number of students that submit their homework on time in time out of the 70 students. And we were given the probability of success to be approximately 85%. So the next set of questions is going to be based on that data. So the first question is, what is the sample space of X here? So we know that the class has 70 students. So basically the sample space should be anything that included the 70. So we see all the integer and we cannot have a decimal student. So it will be all integer. That's why we want the integer that are between 0 and 70. So again, what is very important to understand what the random variable here means. It means that all this x here is a random variable that defines all the students that submit their homework on time. So there could be 0 student that submit their homework in time. There could be 1, just like there could be 70 students that submit their homework in time. So that's why x is a range of value from that. So yeah, that's for the first question. Um, the second question, what is the probability that less than 70 students, less than 60 of the 70 students will do the homework in time? So in order to answer this question, we need to first of all ask ourselves, what probability distribution are we, referring here in this question? Like we know we have a probability of success that was given to us. So the first thing that should come in mind should be something like binomial. And we also need to think about what this represents. So here we're asking the probability that less than 60 out of 70 students will do the homework. So um, so we want basically all the students, including the, because it's discrete and we don't have any decimal. So that's why we take the probability of x less than or equal to 59, because x can also be 59, but just that x is 60 not included. That's because we say the probability of less than, we didn't say less than or equal, we just say less than 60. So that's why it's basically the probability of less than or equal to 59. So basically in R, we just need to use the P binomial. If you recall from a previous video, I did mention that anytime you use P in front of a distribution, it's basically giving you the cumulative distribution. So because we are trying to find the probability of x less than or equal to 59. So basically, if you want to think about this, that means that you're finding the probability of x equal to 0, x equal to 1. So basically, you're adding probability of x equal to 0 plus x equal to 1 plus x equal to 2 until probability of x equal to 59. Instead of doing all the manual calculation, we just use the p binomial 59, which is the upper bound here that we want, and then the parameter for our distribution. So we know that the binomial distribution needs a size, and the size here is n, which is 70 students. And then the probability of success that were given to us is 0.85. So that's basically what R is saying. What R is saying is that it's about 59% basically probability that 60, less than 60 out of the 70 will do the homework on time, which is yeah, that's pretty much the probability there. Okay. Um, so the other question is, what is the expected value of x? We know x followed binomial distribution, so we know from the formula here that the expected value for the binomial distribution is just n times p, or and the variance is this. So basically that's what we use, n times p, 70 times 0.85, and that's the value. So the next question, what is the standard deviation? Again, standard deviation is the square root of the variance, and we know that the variance is n times p times 1 minus p, which is given here in the note. And well, this is the variance that we find, but we ask here the standard deviation, which is should be the square root of the variance. So that's how we get the variance. So that's this question. The next question. So now we have another exercise problem. So again, in chapter 1, it was claimed that when tossing a fair coin 4 times, it's quite likely that you have to obtain 2 head and 2 tail. However, when tossing a fair coin 4,000 times, one should expect to obtain a number of tails in a range between 1940 and 2060. So basically, compare the situation for 2 versus 2,000 coins. Yeah. So let X the number of heads when tossing a fair coin 2 times, and Y the number of heads when tossing the fair coin 2,000 times. So the answer will be okay. Basically, that's that. So basically, we have 2 random variables. You toss the coin 2 times, and you toss the coin 2,000 times. So let's look at the question here. What is the probability that X equal to 1? So again, we need to first of all think what distribution are we referring to here. And again, we see that because we are doing a repeated event, we are tossing the coin. X means that we're tossing the coin 2 times only. And basically, if you toss it, and we know that the coin is fair. If you toss a fair coin, there's only 2 possible outcomes, either head or tail, and each happen 50-50. So basically, we know 50% is the probability of success. So the distribution of X then is binomial. We know N is 2, and we know the probability of success is 0.5. So basically, we need to find the probability of X equal to 1 again, because we want the probability X equal. We need to use the D binomial. It's the density. Remember, the density is giving you the height of the value of this function. Basically, that's what the function usually do. It's going to give you the height of at X equal to 1. So basically, it's going to be this value. So that's a question. In this question now, we are asked what's the probability of X not equal to 1. Well, for X not to be equal to 1 means that we need to take basically the complements, like it's basically 1 minus P of X equal to 1. Yeah, because we either have 2 things, either X equal to 1 or X is not equal to 1. And the sum of the 2 usually will give you 1 option. And again, the reason why we are doing this here is because, like for X, like there are only 2 possible outcomes. Since you're tossing the coin 2 times, and the possible value are 0 and 1. So if X is not equal to 1, because if you look from the definition of tossing the coins, that's usually like the possible outcome that we expect. Yeah. So if X is not equal to 1, X is basically going to be the complement of which is 1 minus P of X equal to 1, which is why we have again a number 0.5. So that's kind of the idea behind this question. There's only 2 possible outcomes for X because we're tossing the coin 2 times. So it can either be 0 or 1. So we know what is the probability of X equal to 1. To find the probability of X not equal to 1, because we know that the sum of probability of X equal to 1 and X not equal to 1 should both be added to 1. Because X not equal to 1 here could be X equal to 0, which is the other side. So, or X equal to the tail, or versus X equal to the head, and so on. That's why we also have 0.5. That's what this means. Now let's look at the other question. Now, what is the probability that Y equal to 1000? We know that Y is the probability of tossing the coin 2000 times. So here again, it's a repeated number of times. So we know it's going to be binomial. And again, it's a fair coin. You toss it 1 time, you have head or tail. So each happen equally likely with the probability of 0.5. So probability of Y equal to 1000, you just use the density D binomial, again just like we did before with the parameters, and give you the value. So we'll come back to the next question in the next video.